Let's talk about another thing here before we go into those examples at the end of the page on page 23, bottom of the page. Intercepts. Any graph, when it talks about the intercepts, that's where it crosses either the x or y axis. So if I've got here, let's say it's this line here, the intercepts are where it crosses the x-axis and the y-axis. Of course, this is the x-intercept. This would be the y-intercept. And we could give it a point here. Let's say that looks 1, 2, 3. Say that one's 3, 0. X-intercept. So the x-intercept is always going to have a 0 for the y. If you think about that. The y-intercept here, let's call it 4. 0, 4. So the x value is going to be 0 for the y-intercept. And it doesn't have us do any of these, but that's how you find the intercepts, is by setting one or the other equal to 0. For example, here, I think I mentioned 2x plus 3y equals 12. Yeah, if it just asked me, okay, what's the x-intercept? Well, you set the y to be 0, because that on an x-intercept always is going to be the case. The y is 0, so if it asked for the x-intercept, we would set the y equal to 0. Of course, that would give us just a little something to solve there, that being 0. So, I don't know, you may have done this in another course, but anyway, and the y-intercept vice versa, you set x to be 0 and solve that. I want to mention that before I move to the bottom of the page on 23 there. So it says, recall that if a linear equation written in the form, all right, so yeah, we're going to talk specifically about the y equals mx plus b form of a line. Okay, so it says recall, so you may have already talked about this, but let's just be sure here. Yeah, that's the so-called slope-intercept form of a line. Because, as mentions there in the note, the m, well, that's our letter for slope, and that is certainly the case here. That turns out this is going to be a line, and it's going to have a slope of m. Whatever that number is in front of the x, that's going to be the slope. If it's in this form, that's what we can tell. And then over here, for the b is the y-intercept for this line. And so that's some pretty helpful information here, because, yeah, that's the rest of these problems on this lesson. They're all about graphing lines. And so this is how, we're going to use that information to graph these lines. Slope, that being the slope, and the y-intercept, and that, well, yeah, so let's talk about graphing some examples here of these lines. All right, so number one is y equals, what was it? 3x minus 1. Yep. Yeah, so this we have m is 3, b is negative 1. All right, so it wants us to graph this line. And so here is what we can do with that. All right, so yeah, the nice thing is, I talked about you have to solve for the y-intercept, x-intercept on, you could do it on this one. So the good thing about this one is B is the y-intercept. B is -1, but that is the y-intercept. Without having to solve anything, but it's really easy to prove that that's the y-intercept because we find the y-intercept. Oh, let's put that 90. The y-intercept's when x is 0, so if you think about it, you set x to 0, you got y is -1. So the y-intercept is -1, so we come over here to the y-axis and put a little dot there at -1, because that's where this graph is going to cross that axis. That's what that means. All right, now the m is 3. That's my slope, which is rise over run. And so that's how we're going to utilize this. M being 3 there, so rise over run, we need two numbers. Well, 3, if we put a number on the bottom, it'd be 3 over 1. And so if I interpret the slope as rise over run here, that's telling me rise of 3, run of 1. Well, obviously, rise of 3 means go up 3. So 1, 2, 3. So we're going from this point. So we go up 3. And then a run of 1. Run is backwards or forwards. That's what that means. So run 1. So that puts me right above the x value 1 there. Yeah, that gives me another point. Two points determine a line. There you go. We have enough information there to graph this. Since I know it's a line, it's a linear equation, x to the first, y to the first. Let me do another one of those. Call it 1A, since next one's number 2. 1A here. Bottom of the page. All right, let's graph y equals minus 5x plus 4. Using slope-intercept form, m and b. M's -5, b is 4. How can I use that? Well, the b, that's the y-intercept, so in this case it's crossing up above the x-axis, on the y-axis at 4. Y-intercept's 4. Got 1 point. M being -5, well, if I want to use slope-intercept, rise over run, let's put that -5 over 1. Now, the deal on that is the negative, there's only one negative in that. And so it either needs to go to the top or you could put it on the bottom, but I usually take it to the top. Because what that means is, all right, so rise-wise, we've got -5. So what is that going to mean? Down 5. 1, 2, 3, 4, 5. So that gets me here to -1. But the run is still 1, which is +1. And yeah, it's positive still. So it's still going to the right here, run of 1. So 1 -1 is the point. So yeah, that is our line, and that again confirms, yeah, negative slope, you're going downhill, positive slopes going uphill. You see 2 more examples of that. Is that okay? Question or concern? All right, number 2. Page 23, bottom of the page. We have y equals -1/2 x. Written that way. Yeah, so that's the same deal. The negative is kind of on the side there, but it is either the top or bottom, not. But why couldn't I do it to both? Why couldn't I have gone -5 over -1? Why would that be wrong? Well, that turns into a positive slope, doesn't it? So you don't want to do both of them negative. Same thing here, put the negative with either the 1. You could do it with the 2. Now the other catch on this one is, what's missing? We don't have the b, do we? Well, the only thing b could possibly be is, there's nothing over here, so the only way we could interpret that is with a 0. Yeah. If you're missing the b term there, you got your m, yeah, the b has to be 0, so if we want to do it according to this method here, there's other ways, of course, table and things like that, but this is a pretty easy way, so yeah, so that b is going to be 0 for number 2 there. So what does that mean? Well, that means it crosses the y-axis. That's my y-intercept. So it crosses the y-axis at 0, which is right there in the middle, isn't it? And we already talked about the m. Do one or the other, negative. So I'm going to go with the top is negative, -1. So that means rise to run. So rise -1, down 1. And then run 2, so that's positive 2, so that's this way. Let's be to another point. And there we have our slope. Negative slope. Kind of one more, call it 2A, I guess, again on that one. What about this one? Y minus 4x equals 0. Y minus 4x. So, like I said, there's other ways of doing this, but if I want to use the same method that I've been using in these previous examples, last 3 examples here, the problem here is this is not in y equals mx plus b form. Right? Y equals mx plus b form, this distinguishing characteristic of that is what? Y is on the side by itself. And so if I want to use this y equals mx plus b stuff, I need to get y by itself. And so wouldn't that mean just we add the 4x over? So we'll have y equals 4x, which looks a lot like the previous one. Now we can use, well, that's my m is 4. The b, well, there's not one showing there, so yeah, you got, again, b is 0. We got this, don't we? Y-intercept 0, b is 0. Slope is 4 over 1. So I rise 4, run 1. 1, 2, 3, 4, rise, run 1, stop. 2 points determine the line, so here we go. Yes? All right. So I'll say we'll have another bout with that here in a second, where we don't have it y equals mx plus b. One of the questions, let me tack on to this one. One of the questions in the assignment asked for to find points on the line. It doesn't say graph it, but what are some points on this line? Well, we got the 0, 0. This point would be 1, what was it, 1, 4? Yeah, 1, 4. And I could keep getting them from this here by using, rise over run. So if I go up 4 more and 1 more run, that puts me what, at 8 and 2, 8, 2. So yeah, plug in values if you wanted to, but I think the way the question's worded, you're going to have to use the graph here to get these points. Is my reason for doing that. So if you just graph the line, then you can keep getting points off of that without even having an equation. But anyway, hopefully that might be helpful for that problem. Anyway, let's go on to page 24. Y equals 4, number 3. First of all, what we note there is, so this one's missing quite a significant part compared to previous examples there. There's no x in it, right? No x in it. Well, if you think about that, so if I come to the graph, really, the key to this one is just recognizing what you got here, I think. Best way to do it. What this is telling me is the y is locked in to be 4. The y value is locked in to be 4. Where's y equals 4? Well, there's y equals 4 here. No matter what x value you have, the y value is 4. So on the y-axis it's 4, on the x equals 1 is 4, x equals 2 is 4, x equals 3 is 4, negative 1 is 4, x equals negative 2 is 4. Those are lining up horizontally there, you see. This is a horizontal line. It's a horizontal line. So missing x, if it doesn't have an x in the equation, you got yourself a horizontal line. Now usually, the way I describe it, a horizontal line formed, you've got y equals a number. Because if you've got that, then you know where the horizontal line is. Because if I have y equals negative 2, the negative 2 tells me where I am as far as y values go. So this is a horizontal line through negative 2. Put my y here. Yeah. So that's the horizontal line through negative 2. So that number tells you where you go. The other thing, I don't know that it asks about this, but the other thing on the horizontal lines, those are horizontal lines, and their slope. Horizontal lines have slope of 0. Horizontal lines have a slope of 0. So it's not positive slope, it's not negative slope, because it's straight across, right? That's 0 slope, in other words. Kind of easy to see that, I think. It has 0 slope. Now, one other one, let me throw at you here. I guess. Y plus 7 equals 0. Well, it's missing the x, so it's clearly a horizontal line, but I would prefer it, right? Subtract 7, y equals negative 7, and that tells you more descriptively, I guess, that this is a horizontal line and the y's are negative 7s. So those are pretty easy to graph if you know what it is you're dealing with. All right, well, guess what? Number 4, page 24 there, x equals negative 1. Well, if y equals a number is a horizontal line, x equals a number is not horizontal because x is always a number there, locked in to be, x is locked in to be -1. And so the y, it doesn't matter what the y values are, the x values are all -1. So yeah, that turns not into a horizontal line, but it's a straight up and down vertical line. So x equals a number, let's call it, if you've got that, you got yourself a vertical line instead of a horizontal line. And if I had more time, I'd show you, but I don't think it has, but just FYI. The slope of that, best way to put it is it's undefined. It's straight up and down, so it's not slanted one way or the other, it's straight up and down. So that undefined slope, if you use the slope formula, you can get that more readily there. But anyway, x equals a number vertical, y equals a number horizontal. All right, just a couple more, and I'm done for the day here. This class anyway. Number 5. 2x plus 5y equals 10. Graph. We're still graphing. Well, the idea here is, in this section, we're going to use y equals mx plus b to graph this. The problem is, not so much, right? That is not y equals mx plus b. Why not? Well, the x and the y are on the same side, and y has a number on it, and we just want y. So, yeah, so that's, we did this in the last unit there. Yeah, so if we want to use that, just solve this for y. This is one way we could go with it. There's other ways, but being in this section, that's what we want to do. Solve that for y. So you subtract the 2x. Of course, it can't combine with the 10 there, so that's 5y equals negative 2x plus 10. Divide off the 5. So that's y equals, and this 5 divides both of those, so it's negative 2/5 x plus 2. 10 divided by 5 gives me 2 there. So now we have m and b. M is negative 2/5, b is positive 2. And so, yeah, that we can graph. The b, what is it? That's the y-intercept. Slope is the rise over the run, so we've got negative 2 over 5 as my rise and run. So that's down 2. Run 5, so that's positive 5. So that puts me right on the y-axis there, x-axis, sorry. So, yeah, that's the idea, I think, for graphing on this one that we want you to use on this assignment here. Is that okay? Questions on that one? Just enough time for one more. Let's talk about this one. This one, there is one of these on the assignment too. X equals 3y. Okay, so y, so if we, we're missing the b obviously, but y here is the slope not 3. Because to get the slope off of the equation like that, it needs to be y equals mx plus b. This is x equals, isn't it? Instead of y equals. So it's just kind of reversed of what it needs to be. So same idea we were just doing here is the deal. I need to solve that for y. If we want to use the y equals mx plus b stuff. So that just means we divide by 3, wouldn't it? So we have x over 3 equals y, or put it in better format here, y equals x over 3, but even x over 3, that's 1/3 times x would be the best way to think of it, wouldn't it? So my m is 1/3, my b, well, there isn't a b, so that's b equals 0. So anyway, is that okay? B equals 0, slope is 1/3, so that's rise 1, run 3. Right over the 3. So that's all on those in the assignments. I was going to give you a heads up on that. All right.